All right, let's kick this up a little bit and just look at what we're supposed to do if there's not an inherent splitting up of fractions. Okay? So what you do is you have to factor out the denominator. So this is going to be a kind of tricky one here. And if we could step up to this notch, this is like level 2 out of like 3 levels. And you're going to be sitting pretty if you can do this one. So if we have something like dt over t squared minus 1 squared, right? It's like, oh, what am I supposed to do with the denominator? Very fair. I'm glad you asked. Well, how can we factor this out is what we want to look at. We need to turn this into something where we can do the partial fraction decomp strat with the variables in the numerator and then split it up into different denominators, different fractions, excuse me. So by changing the denominator. So here what we can do is, what this really is, this is t squared plus t minus 1, right? So that's just t squared minus 1. That's what this is, okay? The inside, t squared minus 1 is equal to t minus 1, t plus 1, okay? And what we do is just factor it out. That's the strategy that you start with if you need to. So it's like the initial thing is like, okay, I need to, how can I make my denominator so that I can actually do partial fraction decomp? What you do is you have to factor it out. So that's what we're doing. But what you need to be careful about is that this t minus 1 squared that's equal to this is squared. This is also squared. So if this is also going to be squared, like what we started with, then we need to make sure that this is also squared as well, right? And so that's what gets a lot of people, is that you need to be careful when you're factoring out. Keep in mind, when you factor this out, what is this actually equal to? It's t squared minus 1, not t squared minus 1 squared. So it's a little bit of an extra thing there. So we figured out that t squared minus 1 is equal to this. And then they're giving us t squared minus 1 squared, so just square that. Okay? So it's a little bit of a tricky thing there when factoring that out. And so just distribute the square. So now we have integral of, I'm just going to do 1 and then put the dt out in front, right? That way it just makes more sense. The integral of t minus 1 squared times t plus 1 squared. Okay? See where I got that? So we did that. That square just goes and distributes out into the two different functions of t there. And then that's how we rewrite that. Okay? Cool. Now we can do partial fraction decomp with that. So when we have the powers of something on the out being applied to the whole function, whereas if it was just t squared minus 1 as a function, then when we plug this into our partial fraction decomp, we need to realize that's a quadratic, and we do ax plus b. Okay? That is entirely different. Your inside function being a quadratic is entirely different than this being t minus 1 squared. And so when it's t minus 1 squared, what we do with our partial fraction decomp is that we build up to it. And I'll just show you what that is, okay? So I'm going to use blue here for this step. So this is going to turn into a over t minus 1, okay? Because that power is being applied to the whole inner function, not just the inner function being a quadratic. So this is going to build up to that power. We have a over t minus 1 plus b over t minus 1 squared, because you build up to it. Plus, now we're on this part, c over t plus 1 plus d over t plus 1 squared. Okay? Now, this is where it is important that you have the understanding where you don't just cross multiply to get to our equation where we can find the values for a, b, c, and d, but you have to multiply by the original denominator to each term. Because how are you going to do that there, right? It's not going to work. So, I am like in the way probably. T plus 1 squared. Okay? Just like that. So, multiply by each term. This is t minus 1 is going to cancel, so it's going to be a times only one t minus 1, since the t minus 1 squared multiplied by t minus 1 is just t minus 1. And that t plus 1 squared is just sitting on top, still being multiplied to the a. So you're just canceling things out with the denominator that are being multiplied to this term. B times t minus 1 squared times t plus 1 squared over t minus 1 squared. The t minus 1 squareds are going to cancel. So it's just going to be b times t plus 1 squared. Okay? Plus c times t minus 1 squared times t plus 1 squared over t plus 1. The t minus 1 squared didn't really get touched by anything, right? But that t plus 1 in the denominator is going to take 1 out, so it's just going to be t plus 1. Okay? C, that's parentheses. Okay. Plus d multiplied by t minus 1 squared times t plus 1 squared. Well, it cancels out the t plus 1 squared, so you're just left with a t minus 1 squared. Okay? And then what do you always do in these problems? You set that equal to the numerator. And that's kind of why, oh, geez, dude, I didn't write the dt. And that's why I just said, hey, this is literally the same thing as this. These are equal to each other. So yeah, this is the partial fraction decomp setup. Now we just do the same thing that we always do. It's just a little more tricky because we have, instead of just A and B, now we have C and D as well. But it's going to be the same process. So what values for t here would be kind of nice to plug in? Well, I see one right now. 1 for t here would be 0, right? So this whole thing, this would become 0, and then this is being multiplied by 0, and this is being multiplied by 0. So this would be 0 plus 1 plus 1 squared. So we would just have, we would have 4b. 1 minus 1, the whole thing would be 0, because this is 0 being multiplied by this and this, so that would be 0. And this would also be 0, so, because 1 minus 1 squared times d, so this would be 0. So we are going to just have a b term that we can find the value for if we plug in 1. So let's do that. If x equals 1, then a times 1 minus 1 times 1 plus 1 squared plus b times 1 minus 1, 1 plus 1 squared plus c 1 minus 1. Why am I writing x equals 1? It's t, isn't it? T. Plus c 1 minus 1 squared, 1 plus 1 plus d 1 minus 1 squared equals 1. Okay? 0 plus 2 squared is 4, 4b plus 0 plus 0 equals 1. b equals 1/4. Divided by 4, divided by 4. We know that b is equal to 1/4. Okay? Now, what's another good value we can plug in for t here? Well, what about -1? Because -1 here would be 0. -1 here would be 0. negative 1 here would be 0. And then we just have d. So what you're constantly doing at this step is you're just looking for values of the variable that the equation is in respect to that will cancel out certain terms and give me the ability to find the other terms. So a times negative 1 minus 1 times negative 1 plus 1, there's how that 0 is going to cancel everything out there, plus 1/4, right? Times negative 1 plus 1, doesn't really matter because that's going to become 0 anyways, plus c, negative 1 minus 1 squared, times negative 1 plus 1, there's that cancel, plus d times negative 1 minus 1 squared equals 1, right? 0, 0, 0, plus negative 2 squared. Be careful, that's 4d equals 1, right? Because it's just the, when you square a negative value, it's that value multiplied by itself. Negative times negative is going to be positive, right? I know that a lot of people are probably like, I know that, but it's such a common mistake. A lot of people don't, or a lot of people miss out on it, I think, and they forget about it, or put it back somewhere where they need to keep it in the light. So we have values for B and D now. Well, how the heck do we find values for A and C? You might be asking. This is where we're going to have a system of equations. So we're just going to plug in what we have for B and D, and then do some easy value that we know is not going to cancel out anything, because we need to have an actual equation relating all the variables. And by all the variables, I just mean 2, right? Because we're going to plug in these. We have 4 variables. We found the values for 2 of them. So we can plug in those two variables that we found, those 2 values for those variables that we found, and then we'll be left with only 2 more variables that we can relate 2 different equations with. And then we could find those variables. So variables, values, holy smokes. I just, keep mixing them up. So what we have to do is do some kind of easy value. So let's just do 2. So A times 2 minus 1 times t plus 1. T is 2 here, geez. 2 plus 1 squared plus 1/4. 2 plus 1 squared plus c 2 minus 1 squared times 2 plus 1 plus 1/4 2 minus 1 squared equal to 1. And that d, I did plug in 1/4 for d, okay, nice. So here, we need to try to get an equation for A and C, right? That looks like a C. So let's just do this out. So 3 squared is 9, 2 minus 1 is 1, so 1 times 9 times A. We have 9A, okay? 2 plus 1 is 3, 3 squared is 9, times 1/4 is 9/4. 2 minus 1 is 1, 1 squared times C is just C, so plus C. Oh, times 2 plus 1, so you gotta be careful with your algebra. So this is the whole term. So 2 plus 1 is 3 times 1 is 3C plus 2 minus 1 squared is 1 squared, plus, which is 1 times 1/4, so just 1/4 equals 1. Okay, let's add our fractions together. 9A plus 9/4, or sorry, 9/4 plus 1/4 is what? 10/4. Plus 3C equals 1. All right. Now, what's 1 minus 10/4? Well, let's multiply this by 4. Okay? 4 minus 10 is -6/4. And what's that equal to? that is going to be equal to negative 3 over 2. Okay? And that's why 9a plus 3c is going to equal to negative 3 over 2. All right. So we got one equation relating A and C. Now we just got to find the second one. What can we do for that? Just plug in a different value for t, and you'll get a second equation. That's literally all you can do. You do any value. We're going to do 0, because you just want to do easier values, right? So, yes, it's kind of tedious, but it is just a lot of algebra. Welcome to calculus. 0 minus 1, 0 plus 1 squared plus b, which is 1/4. 0 minus 1 times 0 plus 1 squared plus 1/4. 0 plus 1 squared plus c times 0 minus 1 squared times 0 plus 1 plus 1/4. 0 minus 1 squared equals 1. All right. A is negative, we got negative 1 times 1, so negative a, plus 1/4 times 1 squared, which is 1, so 1/4 times 1, so just 1, plus c. Here's, you gotta be careful. Negative 1 squared is positive 1, because it's negative 1 times negative 1. So it's c times positive 1, so it is plus c. And that's just times 1, right? Plus negative 1, again, negative 1 squared is positive 1, because it's negative 1 times negative 1, which equals positive 1. So it's positive 1 times 1/4, so just 1/4 equals 1. Okay? All right. So 1 minus 1/8, well, we can rewrite 1 as 8 over 8. This becomes 7 over 8. All right, so 1/4 plus 1/4 is what? It's 1/2. So negative a plus c plus 1/2 equals 1. Okay, 1 minus 1/2. So we write that as 2 over 2. It's 1/2, right? I always write out my fractions without even thinking about it, but yes, you take half away from 1, it's going to give you half, so yeah. So negative a plus c equals 1/2. Okay, we have a system of equations, because we have two equations relating to two variables. So now what we can do is we can set those to each other. Okay? (9a) plus 3c equals negative 3 over 2 plus, let's do that over here, negative a plus c equals 1/2. Okay? What can these are being added to each other. That's what a system of equations is. What can I multiply this whole equation by legally that can cancel out either c or a so that I can find one of the values? I noticed two things right away. I can multiply this by negative 3 so that the negative 3c would be added to the 3c, or I can multiply just everything by 9. And I think I'm going to do that because that's kind of just what jumps out at me. I have a 9a and a negative a, so if I multiply that by 9, it's going to give me negative 9. So multiply this by negative 9. Oh, I'm sorry, positive 9, because that's already negative. There you go. So now we have 9a plus 3c equals negative 3 over 2. And then we have negative 9a plus 9c equals 9 over 2. Now that's being added together. And this will give us 9, 10, 11, 12. 12c equals to negative 3 over 2 plus 9 over 2. Negative 3 plus 9 is 9, 8, 7, 6. So 6 over 2, which is equal to 3. 3 times 2 is 6. 6 over 2 is equal to 3. And then we have c equals 3 over 12, which is equal to what? Divide by 3, divide by 3. 1/4. Okay? C equals 1/4. Now, if you want to make this hard on yourself, to find the last variable, we need to find a. We could take this whole equation, plug in something easy like 0 or 2, and then plug in all of our values for the other three variables and then find a. Or we can just grab one of these equations that we already found that are literally true, and then just plug in one of the variables for that and then find a with that. So that's what we're going to do, and I'll show you what that is. Negative a plus c equals 1/2. See where I got that from? We found that equation. Now we can plug in our c value for the variable. Jeez. Right? And then 1/2 minus 1/4 times 2 is equal to 1/4. So negative a equals 1/4. A equals negative 1/4. Okay? We did it. So we now know b is equal to 1/4, d is equal to 1/4, that c is equal to 1/4, and a is equal to negative 1/4. Okay? So I like to usually write that all out. Oh my gosh. We got all the values. All right. Lots of algebra. Lots of algebra. Now that you did all of this algebra, it's time for calculus to solve the problem. So we need to take an integration. So what we actually have here is the integral of a, which is negative 1/4 over t minus 1, plus b, just 1/4, over t minus 1 squared, plus c, which is 1/4, over t plus 1, plus d, which is 1/4, over t plus 1 squared, dt. Now, the integral might look scary, but I promise you, we're going to get through it. All right? Split it up. Take the negative 1/4 out. Negative 1/4 over 1 over t minus 1. Plus 1/4 integral of t minus 1 squared, plus 1/4 integral of 1 over t plus 1, plus 1/4 integral of 1 over t plus 1 squared dt. And don't forget your dt's. Don't forget your dt's. I have no room. But they can technically just go in the numerator, so that's what I'm going to write them as. Okay. So we split it up. Okay. Now we just need to do a bunch of u subs. u equals t minus 1. What's the derivative of t minus 1? It's just 1 dt. So this becomes negative 1/4, 1 over u du. Okay, this becomes u t minus 1 squared du equals 2 times t minus 1. Okay. Okay, and then that would become 1/2 du equals t minus 1. So that would not work. And so this is when you have to look and be like, okay, u sub doesn't work there. Oh. Okay, so this is when you have to look and be like, okay, I can't just pull the t minus 1 squared. I need to just pull the t minus 1 like I am with the other problems. Because when you end up subbing it with u, you'll just have u squared. And so you can definitely do that. So u equals t minus 1, du equals 1 dt. Derivative of t minus 1 is just like 1. So, and then 1/4 integral of 1 over u squared. Don't forget that squared, okay? Because u is equal to t minus 1, and it's being squared. U equals t plus 1, du equals 1 dt, 1/4 times the integral of 1 over u du. This is du. U equals t plus 1, du equals 1 dt, 1/4 the integral of 1 over u squared. All right. So don't let the trends of what we've been doing mess you up with these 1 over u squareds, because that is not a natural log. That is just an antiderivative of this, okay? Because 1 over u squared is equal to u to the power of -2. And what do you do with the antiderivatives? What you're actually always doing is x to the n plus 1 over n plus 1. Okay? So -2 plus 1 is -1. So that becomes -1 over -2 plus 1, which is -1. This is what we end up getting when we take the integral of 1 over u squared. Okay? So this becomes -1/4 natural log of u, which is t minus 1, plus 1/4 u to the -1 over -1, plus 1/4 natural log of u, which is t plus 1, plus 1/4 u to the -1 over -1, plus c. All right, how do we make that just look a little bit more pretty? Well, we have -1/4 natural log of t minus 1 plus 1/4. We pull that negative out, minus 1/4 of u, which is t minus 1, to the power of -1, which is the same as t minus 1 at the bottom of the fraction. Okay? So u is equal to t minus 1. Being divided by -1 just means it's negative, so I just pulled the negative out. And then u to the power of -1 is just 1 over u. So I did 1 over u, which is equal to t minus 1. Plus 1/4 natural log of t plus 1, right? Minus 1/4 of 1 over u, which is t plus 1. 1 over t plus 1. Let's see. All right. There you go. That's the answer.